Hi. Right, let's do a little demo of how to use the Open Data Portal API so that we can understand how to use it in practical circumstances and get some useful output from it and understand where it adds value and why it's a good option for dynamic and online analysis. So here is my R working environment. I'm using something called Positron, which is a newer version of RStudio. And I've written a script which will help us get data from two data sets on the Open Data Portal and join it and map it. So what we're going to do is use the Broadband provision, the BDUK data set, and we're going to look at which LSOAs have low provision of current and future gigabit broadband. So we're going to get count of the properties where there is no current or future gigabit broadband by LSOA, and we're going to map it onto and have a nice thematic map which shows the distribution across the region. So the first thing we need to do is load up some libraries in R, and this is the set of libraries we're going to use. And I'm going to run this line by line, or code chunk by code chunk, so you can see what's happening. Let me just clear this. Right, so first of all, we're going to load the libraries. So we click Control Enter, it runs that, it's loading up the libraries. Now, while that's running, we can have a look at the API console and see how to construct the URL for a API call. So this is the API console that you can get to through this URL. And we're going to go for the records endpoint, as we can see here. And what you can do in the console is enter your search terms and your key components of the API URL and test it in a real environment so you can see what data comes back. So here we're adding in the name of the data set. Here we're adding in the fields that we want. So we're getting the local authority, the LSOA code, and then we're also doing some calculation on this in this box, in this select clause, where we're counting the number of UPRNs, in other words, the unique properties, and we're renaming it as premises. So we'll get three fields out of this: local authority, LSOA code, and premises. And we're having a filtering criteria here in the where clause, where current gigabit is false and future gigabit is false. These are Boolean variables and they're true or false. So by adding in this clause, we're saying, give me the premises where there isn't future or current gigabit. And we're grouping by local authority and LSOA code. So we're going to get the count of premises which don't have either a current gigabit or future gigabit availability. And that's all we need really to run this API call. So once we filled that in, we can scroll down and we can execute this query, and that will run that API call. And I've already done it, so I don't need to do it again. But this is the kind of output you'll get. And notice that 200 means a good response, and you'll see that verified here because we've got the actual JSON here, and you can see that we've got in this JSON object a total count, so 491 records, and then we've got the results here, which is a JSON array of objects with the three fields here. So that's all reassuring. That's the kind of thing that we want. But we can use this request URL back in our R script. So we can copy and paste that and go back to our R script, and we can paste that in here. And the reason why I'm doing that is because I want you to see that this is quite a long, ugly URL that's quite difficult to deal with and quite difficult to understand and difficult to do anything programmatic with. But this Earl parse function, which is part of the hitter HTTR2 package, which is built for API work, can help us understand the different components of that long URL. So if we run that, we can see that we've got these components that are nicely broken down, and we can understand what they are. So you can see that you've got the select clause, the group by clause, the where clause that we did in that other console. And what we can do is assign the values that we want to appear in there as variables. So here we've assigned a variable called bduk endpoint to the word records. Dataset is the name of the dataset, etc., etc. So if we run all these, if we run these, so these are the universal variables that we're going to use in other API calls. So we can run all of these. And we're now, if you look on the right-hand side of the screen, you can see those variables are being put into the environment. They're now available to us, and we can use them to build the API call and get the response. So this is where you get that response object from the API call. And if you look at it, you can see what we're doing. We're requesting from the host name, which is the base URL. We're building up the path of the URL for the API, and then we're inserting these essentially these SQL clauses and these components of the overall API call. And then finally, we pipe it using this little symbol here into the perform, rec perform function, which goes and gets that API response, and it assigns it to this variable called bduk response. So let's run that. And it's gone off to get that pretty quickly. So what that's done is actually query nearly 500,000 records very, very quickly, and do that aggregation and return you the summary response. So now we need to just do a bit of processing on that response. And what we're going to do is create the table object, so a data frame that we can then use in further analysis. And what we need to do there is just apply, recognize that that's a JSON object, and get the results object from that JSON object, and then bind all the rows together so that it creates a nice table. And if we run that, it's done that, and then you can actually inspect that. Just double click on the data there, and you can see that that's the kind of output we're expecting, with local authority, LSOA code, and the number of premises. Right, so that's the first part of the API operations. We've got one data set using the API. Now we're going to get the LSOA boundaries as a spatial object from the platform again, and we're going to join that no gigabit data onto the LSOA data and make a map. So these are the specific variables we need for the API call. We need the dataset ID, we need the two fields, LSOA code and the geoshape, which is where the geospatial data is stored. And we're going to use the exports endpoint, and we're going to get it as an FGB file, which is a efficient geospatial data format that can be used to reduce the size of the payload that you'd otherwise have to use with a GeoJSON, which is quite a large type of data file. So we can now run these variables, which are going to be used in the API call, and you'll see them appearing on the right-hand side. And now we're going to do that API call by assembling those variables and the path name. We're going to pipe the output from that call into this part here, and stRead is a function from the SF library which reads spatial data, and it's a special type of data in R, which means that you can then produce maps with it. So if we run that, it'll take a little bit longer because it's getting some spatial data, and that should eventually, or quite soon, complete. Yeah, so if you look down here, you can see that it's verified that that is a spatial data set. It's a multi-polygon, and it's got a bounding box here showing the minimum and maximum coordinates, and it's in WGS 84, which is latitude and longitude. So now what we need to do is just to do a simple operation where we join those two data sets that we got through the API by their common field, which is the LSOA code. They're named slightly differently here, but that's the right data. And so we're only going to retrieve those data sets which have those rows which have correct values. So we're not going to get all of the LSOA boundaries here, but we're going to create this LSOA no gigabit SF dataset. And let's just have a look at that because that's interesting to see spatial format. So if you double click on it, you'll see that we've got the three fields that we expect, and then we've also got this geometry field, which is what you get with SF datasets, which has geometry data in it. So it has latitude and longitude points around a polygon. Cool. So we've got a spatial data set. Now all we need to do is map that data set. And we do that using the tmap library here. And what we're doing here is we're setting it to a mode where we can see it in a view. We're saying we want a base map using the OpenStreetMap layers. And then we're adding in our created spatial data set. And we're just creating some color and transparency parameters in our TM polygons function call so that we can see the different graduation of colors according to how many premises have no current or future gigabit availability. So let's run that code now. And it's going to take a little while because it's doing some rendering behind the scenes. But you can see there a map which shows the LSOAs with no gigabit or current or future gigabit coverage. So you can actually zoom in on that and get interactive data. For some reason it's not doing that right now, but you can see which, where you've got coverage and where you're not, and where you've got poor coverage that you might need to address through investment or programs. Okay, so I hope that's useful. It's a quick demo of how to use the API in R, but it's a similar process to use that in Python or other programming languages. So I will stop recording there. Thank you.